in this lecture I will explain you how to generate the pulse amplitude modulation and how to demodulate the pulse amplitude modulation. Okay, so basically in your syllabus you need to remember the block diagrams, how to generate and how to demodulate it. Okay, so there are two types. So first one is natural PAM and another one is flat top PAM. Okay, natural pulse amplitude modulation and flat top pulse amplitude modulation. So what will happen is natural, I already explained you how to make this natural one. This is the natural PAM. Okay, and next one is flat top PAM. What does that mean? Flat top means like this, simple. The top is flat. So this is flat top. So I can write, what is that? Pulse top shape which follows the modulating signal. Okay, and in this amplitude is constant, so it is the constant one. Okay, so these are basically two types, the natural PAM, this is the natural PAM in this, and the next one is flat top PAM. Okay, now you need to know how to generate a PAM signal. So generation of PAM, how to generate the PAM signal. So for this, first of all, the first block is low pass filter. Second block is multiplexer, and the third block is modulator. Okay, so when we are passing the signal from low pass filter here, okay, suppose I am passing like this signal, a simple sinusoidal waveform, and this signal is xt. Okay, and now it is passed through multiplexer here. Let me draw this first. Okay, so it is passing through low pass filter first, and then it is a sinusoidal waveform. What does this low pass filter does? Low pass filter, basically what will happen, it will limit the bandwidth. Okay, and then it will multiply with the carrier signal CT. Okay, so here I can make another block which is here pulse generator. The pulse is generating. Okay, let us I will show you how the pulse is generating here. So this is the pulse, it is generating the pulse, right? So this xt is transferred through low pass filter. So low pass filter will limit the bandwidth, and then it multiplies. See, multiplexer is here. This is the multiplexer. So multiplexer will multiply this xt and then multiply this pulse from this generator. Okay, and then it will pass through the modulator. So what will happen? A modulated waveform we will receive, because it is PAM. So you know what is that PAM means. PAM is this one. So I'm just going to copy this here. Yes, so this will be your PAM. Okay, let us remove this. So I will just receive this waveform like this. Okay, so this is a PAM waveform. So I hope you understand this. So you need to remember the block diagrams. Block basically, and this is your CT. CT is the carrier wave here, and this is the modulator. A simple block diagram, and I can write what is XT. XT is the modulating signal, and CT is the carrier signal. So what will happen basically? Modulating signal, it's just the explanation I'm writing. Modulating signal is passed through LPF. Modulating signal is XT. LPF is low pass filter, which limits the bandwidth, and then it multiplies with the carrier signal CT. It will multiply with the carrier signal CT and gives us a PAM signal. So we will receive a PAM signal. Okay. And what do you mean by band limit? I explained you what is band limit basically. Basically, if we need to pass certain frequencies, in certain frequencies we need not to pass. So this is basically the band limit. Okay. So it will pass this frequency, and it passes certain frequencies, and rest of the pulse amplitude is 0, and rest of the pulse amplitude is 0. Okay, so this is your band limit thing. Now if you need to draw the waveform, so in exam if it comes, then you need to make the block diagram, you need to explain it in 2-3 lines, and you need to make the waveforms. So I'll make the waveforms of PAM. For making the waveforms, what do you need? A modulating signal, simple. So suppose this is the modulating signal. Second thing, what do you need? A pulse So this is the pulse, I am drawing it here. Okay, and next is your sample signal. So if you need to make the sample signal, I explained you how to make the sample signal. You will just make the dotted one, and then you will make this one. Okay. So this is your sampled signal. So because it is PAM, the amplitude is varying. So I can write this is your modulating signal, sampling signal, and this one is the sampled signal. Okay. So or I can write it is the baseband. Baseband or modulating is the same thing. This is your carrier and this is your modulated signal. Okay. So this is all about the PAM, how to generate it. And next is demodulation of PAM. If you need to demodulate it. demodulation of PAM. Okay, how to demodulate it? It's very simple. We will use two blocks. The first one, the another one, and we are giving the PAM signal and we are passing through the equalizer, and then we will be okay. So what do you mean by demodulation? Demodulation means, first of all, we generated the PAM signal, right? In this we generated it, but now if we want to recover it back, how to do it? So for doing it, we will pass the PAM signal because we need to recover it what we have generated it. So it will be passed through the reconstruction filter, okay, and then it will pass through the equalizer, and then we will get the original signal, the XT. Okay, so this is the block diagram of the demodulation of PAM. Remember, cut off frequency of reconstruction filter is more than the maximum frequency in message signal. Okay, remember FC will be greater than F max. Okay, cutoff frequency will be greater than this. Reconstruction filter reconstructs the PAM signal and rest is cut off. Reconstruction filter reconstructs the PAM signal, okay, and rest is cut off. And what does this is the function of reconstruction filter, and second is equalizer. What does the equalizer do? Equalizer helps in maintaining and balancing any attenuation if it's there. Okay, so this is basically the function of reconstruction and equalizer. Okay, reconstruction filter reconstructs the PAM signal and equalizer helps in maintaining and balancing the attenuation. Okay, next is advantages of PAM. Advantages of PAM. So the first one is, it is a simple process for both modulation and demodulation techniques. Very simple process because it requires only a few blocks. Okay. Second, no complex circuitry is required for both transmission and reception. Okay, and what is the third advantage of this? PAM can generate other pulse modulation signals and can carry the message or information at the same time. Okay, so there are three advantages of this. See, you need to remember all the advantages and disadvantages. So first one is very simple process. Second is no complex circuitry is required, And third one is PAM can generate other pulse modulation signals and can carry the message or information at the same time. Okay, so you need to remember these advantages of PAM. Okay, just converting it. So it is a simple process. Now next and the last topic of this PAM is the disadvantages of PAM. So what are the disadvantages of PAM? Bandwidth will be large. Bandwidth will be large for transmitting the pulse amplitude modulating signal due to Nyquist criteria. High bandwidth is required. Okay, so remember this is the disadvantage, that in this one high bandwidth is required. Okay, and in this one the amplitude, you know that amplitude varies according to the modulating signal due to these variations in the signal, interferences will be there. So noise will be more. So what is the first disadvantage? The bandwidth will be large, and in this the noise will be more. And the third one is pulse amplitude signal varies. So power required for transmission will be more. Okay, so please remember what are the three disadvantages of this. Bandwidth will be, whatever bandwidth will be required will be more. Because the amplitude varies according to the modulating signal. So due to these variations, the signal interferences will be there and noise will be more. Okay, remember there will be more noise. And the third one is pulse amplitude signal varies, so power required for transmission will be more. So power required is more, and okay, and noise will be more. Here I can write it. Noise will be more. So these are the three disadvantages of PAM. Okay, and the last one is applications of PAM. Applications of PAM, where I can use this technique. Okay, the first one is Ethernet communications. You can use it in Ethernet communications. Second one is photobiology. That means when someone studies the photosynthesis. Okay, and third one is many microcontrollers it used. Okay, so these are the three application areas where it is used: Ethernet communication, photobiology, and microcontrollers. So this is the application of PAM. So in exams, what you need to remember is, now I will explain you again. You need To know, you need to know the generation of PAM, the block diagram of it. Remember, only 4 components: low pass, multiplexer, modulator, and pulse generator. Next, you need to know the waveforms. And next, demodulation of PAM, the block diagram. Okay, and advantages of PAM, at least 2 advantages, disadvantages, 2 disadvantages, and application, at least 2. Okay, so this question can come in 10 marks and you need to do each and everything, whatever is mentioned in this video. Okay.